Well, good morning everyone. So we've spent a few lessons where I've been showing you the rules for your basic quadrilaterals and triangles, finding the area and perimeter. We're going to start looking at some GCSE style questions today. We're going to look at the simpler ones, but then I'm going to finish off by showing you one of the trickier ones on the worksheet later on, and I'm going to ask you to have a go at that before next lesson, and then we'll go through that one first next lesson. But if you could upload what you do to that for me, then that'll help me in the way that I explain things to you that time. Okay, great. Well, let's crack on with this then. All right, so here's question 1. Have a look at this. Make a sketch of it if you haven't got the sheets printed off. Take your time and have a go at it before watching me demonstrate what I would do. So shape P is a triangle. Now you can't count the squares. You can count a few of them, 1, 2, 3, 4, 5, 6, but you can't count these others, so you need the formula. So the formula for a triangle is a half the base times the height, or base times height divided by 2. And when we say height, we mean perpendicular, so it's got to be at right angles. So this is 4 from there to there. That is the base. And the height at right angles is going to be how many squares high it is. 1, 2, 3, 4, 5, 6. So 4 times 6 is 24. 24 divided by 2 is 12. You could also halve just one when you times and then divide. It doesn't matter which order you do it in, actually. You know that whole thing of BIDMAS? Really, the adding and subtracting, because they're the opposite of each other, are held as, so you have to do the brackets, then you do the indices, then you do division or multiplication. Anyway, I digress. Write down the mathematical name for shape Q. Well, this has got no right angles, but it's got 2 pairs of equal parallel sides. So that is why it's called a parallelogram. Now, if you misspelt it a little bit, you wouldn't lose the mark. There'd be 1 mark for it. As long as you wrote something that looked somewhere close to it, they would give you the mark. Next question. Find the area of shape Q. Well, that is base times perpendicular height. So it's actually a little bit simpler. The base is that 3 there, and the height is 1, 2, 3, 4, 5, because there's your right angle. So it's how high it is, not the length of that sloping side. So 3 times 5, which is 15 centimeters squared. Now you could actually have reasoned this one out by counting squares. I'll just show you why. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 whole squares there. And then if you think about it, that triangle there is going to be half of that rectangle there, and that triangle there is the same size as this bit down there. So this part here, if you were to cut it out, you could slide across and put up there. So it is actually going to be another 1, 2, 3, 4, 5 squares on top, which gets us to 15. Right, this question is going to make you think a bit more. So write down what the words say at the top and use the squares that you've got there. If you've just got a squared book, you could use those as well. But you need to think about what's being said. You've got 2 bits of information. The perimeter of the rectangle is 24 centimeters. The length is double the width. So if we said that the width was W, the length, we could say, is 2W, isn't it? Now, what would the perimeter be? The perimeter would be, do you remember we said that you would add the length and the width together and then double it? Well, 2W plus 1W is 3 widths. So we're going to have 2 times 3 widths. So that means 6 widths altogether, or 6W. But we know that all of that adds up to make 24. So I can say 6W is equal to 24. So if 6 times a number is equal to 24, we divide both sides by 6, and that would give you the width is 4. Now once I know that the width is 4, 1, 2, 3, 4, I can draw that in, and then it says that the length is double of that. We should then go 1, 2, should use a ruler really, 3, 4, 5, 6, 7, 8, and then up 4 and across 8, so we've got 8 centimeters and 4, and I can double check that this is right. 8 plus 4 is 12, 12 times 2 is 24, so we've solved it. Now here's another question similar. Now they like these, and the key is making an equation. I know a lot of you don't like the idea of making an equation, but just write down mathematically what this means in terms of calculations, in the same way that we did the time before. So here's my sketch of my rectangle. The width is W. They're telling us the length is 3 times. The length equals 3 times W, which we can call 3W. Now it says the area of the rectangle is 48. Now how do we work out the area? Area equals length times width. So the area is going to equal the length times the width. What do we call W times W? We call it 3W squared. That is the area. And they've told, I've put equals 48 because they've told us that there. Now how do I solve this? Well, I can solve it one bit at a time using reversing BIDMAS. The little squared bit, that is a power, that's indices, so that would happen first in the calculation. When we undo it, we go the other way, so the multiplication must be got rid of before. So we undo multiplication by dividing, so that would give me my width squared is equal to 48 divided by 3. How many 3's in 48? 1 in 4 with 1 left over. 6 3's are 18, so it's 16. Now if the number squared, I'm looking for the number that's going to be the opposite of that, is called square rooting. If I square root both sides, that gives me 4 centimeters as the width. And so if I draw my 4 in, this time I will use a ruler. So here we go, 1, 2, 3, 4. And then we need it to be, that's the width, the length is 3 widths, so the length is going to be 3 times 4, which is 12 centimeters. So my paper's been, I printed it off a bit smaller, so actually I need to count the squares, not the centimeters on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is where it goes to, with that being 12 centimeters and that being 4. Now is there another way you could find it? There is another way you could find it. If you don't like doing that algebra way, you could say to yourself, I know the area is 48, so I know I'm looking for two numbers that multiply together to be 48, and then for those numbers, one of them's got to be 3 times bigger than the other. So you could go the factor route. What makes 48? 1 times 48. Then 2 goes in 24 times, but 24 is 12 times bigger than 2, so it can't be those. 3 goes in, we just did that, didn't we? 16 times. Now 3 times 4 is not 16, so it's not that. 4 goes in 12 times, and 4 times 3 equals 12. So you might find that an easier way of solving the problem. However you do it is up to you. Just going with algebra, as long as you take your time, always gets you there. But there are many other routes very often. Question 4. So, very similar to what we had before. The base of a triangle is twice the height of the triangle. The area of the triangle is 16 centimeters squared. So we know that the base is twice the height. So if they're telling us that the height, let's just make a sketch first of all. If we call that h, the base is no longer h, but it's 2h. So you could go that way, or we could try the other thing, couldn't we? That we know that the base times the height divided by 2 is 16. So if you were working this out, then the base times the height would have to be 32, wouldn't we? So we're looking for two numbers where one of them is twice the other and they multiply to make 32. So what are our factors of 32? 1 and 32. Half of 32 is 16, so 2 times 16. 3 doesn't go in because 10 3s are 30 and 11 3s are 33. 4 goes in half that number of times. Now, 4 is half of 8, so it must be 4 centimeters base, and 1, 2, 3, 4, 5, 6. They've not given us. Oh no, the base is twice the height, so that's why 5, 6, 7, 8. And then if we go up, now it doesn't matter exactly, we could go right in the middle, or we don't have to, but 1, 2, 3, 4, as long as we have got a vertical distance of 4 squares, your triangle could have a point anywhere up there. What I mean by that is if I do another one in pencil, I could, if I wanted to, go to that point, and that would still have the same area and it would still have the same height and base. On to question 5. So it's a similar problem. Take your time, write down what those first two sentences say and see if you can write it down in terms of the formula. Remembering the formula is the base times the perpendicular height. And the base is going to be twice the perpendicular of the height. And they're multiplying together to make 50. So actually I think this factor route is easier. Could you please, first of all, find all the factor pairs to 50 in the way that I had done just before, starting with 1 and 50. But 50 is 50 times more than 1, so it's obviously not those. Half of 50 is 25. 3 does not go. 4 does not go because 12 4s are 48. 5 goes in 10 times, and 10 is twice of 5. So the base is twice the perpendicular height. We need a base that's 10 centimeters long, or 10 of these squares, because they've called it a centimeter square grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I've got to go up 5. 1, 2, 3, 4, 5. Now it doesn't matter how much of a parallelogram. I could, as long as it's not 90 degrees, I could go to there, I could go to there. Because I've only got 2 squares going off there, I can't go more than 2, can I? I could if I'd set it up a bit further over there. So I'm going to do that. And that would get me the full mark, but just to make sure, I'm going to write down 10 centimetres for my base and 5 centimetres for my perpendicular height. Here's a nice question. Copy it down. It wants you to work out the perimeter. I suggest you draw these out and put all the numbers of 7s and 4s that you could possibly make up and see if you can make up all of the numbers. You need to just know the distance around the shape. So pause the video and give it a go. Right, so that's 7 centimetres. From there to there is 4. From there to there is 4. That is 4. That is 7. And that is 7. So the one bit we need to work out is this distance here. Well, from there to there is 4. From there to there must be 4. And if from there to there is 7, 4 plus 3 makes 7, so that must be 3 centimetres. So now we just need to do 7 and a 4 and a 4 and a 7 and a 3 and a 4 and a 7. Add all of those up. Actually, I'm thinking there's a lot of 7s going on here. I've got 1 7, 2 7s, 3 7s, 4 7s. 4 times 7 is 28, and then those two make 8, don't they? Add the 8 gets me 36 centimetres, and as long as you put that on the dotted line, your units are counted in. Right, now this is a question I'm going to leave you with, actually, question 7 today. What do you think? A square has an area of 64 centimetres squared. Find the perimeter of the square. So you need to think about how you work out the area of that square, what a side is, and then you've got 4 of them around the outside. And we'll carry on with that next time.